All right, I want to mark on these just a little bit more. Okay. So just to go through the things that you wrote real quick, and I know I have a bunch of stuff going on. Let me cover some of this stuff up so you don't have to look at all of it. Okay, the first thing you wrote is that there's one pair of parallel sides. Okay, so we have one pair of parallel sides in our trapezoid. That's why you see the arrows here. And then it says that we have one pair of congruent sides. So that's why you see the tick marks there. So the non-parallel sides, they're congruent. Okay, the other thing it says is that the angles along the legs are supplementary. And you guys wrote down in your foldable that these two angles, A and B, add to be 180. And these two angles, C and D, add to be 180. So these are the angles along the legs. So if you look at the front of the foldable, the parallel sides, those are called the bases. So these guys right here are the base angles. These guys right here are the base angles.
Like, I thought you were asking.
No, I just want people to stop talking. The sides that aren't parallel are the legs. So these are the angles along the legs. Okay? So you guys wrote down that the angles along the legs are supplementary. So A and B add to be 180. C and D add to be 180.
I didn't get it.
Okay, I'm sorry. I had it up there for a really long time.
Can we draw them?
Okay, you guys already have this picture drawn, right?
Yeah.
Okay, and then base angles are congruent. So let's put these curves in. B and C are base angles, and they're congruent to one another. And A and D, those are base angles, and they're congruent to one another. So I was just trying to get some vocabulary into you. The sides that are parallel are bases. So A and D are base angles because they're up against the base. B and C are base angles because they're up against the base. So base angles are congruent to one another, but angles along the legs, those are supplementary. Okay, then, do you have room to put another picture below that? Okay. I don't actually have a problem to practice this today, but we can practice it tomorrow or another day. So, draw yourself another trapezoid, and I need you to write down this statement and this statement, and then I'll talk about what I mean.
Where do you want us to draw it?
Well, I was hoping you'd have room below the other picture. So draw this trapezoid and write these two statements.
Are we going to be able to use this on the test?
Literally right here. When I say mom, like move around. Yes, I see it.
Getting comfortable?
I think you got it.
You did what?
Okay, if I have time today, we'll do a problem about this. But if MN is the median, it's half the length of these two lengths added up. So if MN is the median, it's half of these two lengths added up. Okay, we need to add several things to the kite picture. Okay, in a kite, we're told that these two sides here are congruent, and these two sides right here are congruent. So, let's talk for a second. Remember when we were proving triangles congruent? Side, 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 angle, side, all that?
Yeah.
Okay, so if you could zero in on this big triangle here and this big triangle here, I have a side congruent to a side, another side congruent to a side. Would this segment right here be congruent to itself?
Yes.
So, why do you think these two triangles are congruent then? This big one and this big one. If this is congruent to itself, I just don't want to put the tick marks there. If this piece is congruent to itself, why is this left triangle congruent to this right triangle? Side, side, side. because I have 3 sides on this triangle congruent to 3 sides on this one. So we learned that if triangles are congruent, all their corresponding parts are congruent. So that means lots of things. That means this little angle is congruent to this little angle. It means this whole angle here is congruent to this whole angle here. And it means that this little one down here is congruent to this little one down here. Okay, something else besides that. I kind of want to focus in on this top triangle. Can you guys back there please try to stop talking?
I'm alone.
It would be really nice. Hi. We don't need to say hi. I just need you to not talk while I'm trying to talk. I want to focus on this triangle. Do you see how these 2 sides are congruent? What kind of a triangle is that if those 2 sides are congruent? That's an isosceles triangle. And remember how we learned that if 2 sides are congruent, the angles across from them are congruent? So I know that this angle will be congruent to this one. So what that means in my kite picture is that these 2 little angles equal. I know this whole angle equals this whole angle, but because this top one is an isosceles triangle, I know that those 2 actually equal each other as well. So I just kind of drew that off to the side.
In the middle, like where those 2 things cross, would those always be 90?
Did we write in there about the... Oh, we did. We need to put that in there too. So hang on. I'll get there. And then let's focus in on this triangle. Do you see how in this big triangle that these 2 sides equal? Yeah. So what kind of a triangle is this one? It's isosceles as well. So this little angle will equal this little angle. So what that means is, in this big part of the kite, these 2 angles equal each other as well. So not only do these little tiny ones equal, and these equal, this whole big angle and this whole big angle equal. Okay, the other thing you wrote about the kite is that diagonals are perpendicular. So if diagonals are perpendicular, what's that mean?
Wait, what?
If diagonals are perpendicular, what's that mean? They form 90-degree angles in the center. What other shape does that?
Parallelogram.
Not the parallelogram. The rhombus. The rhombus also has diagonals that are perpendicular, so the rhombus also has 90-degree angles in the center. So now the kite has 90-degree angles in the center, and the rhombus has 90-degree angles in the center. Okay, so let's go to the notes. Okay, this is just going back over everything that we had in the foldable. It teaches you about vocabulary. These are your bases, so these guys are the base angles, these guys are the base angles. Okay, going through this, let's look at number 1. When you look at the 102, which one is the base angle that would be congruent to the 102? The Y. Okay, so some of you might not have heard me. The bases are the parallel sides. The angles that are up against the parallel sides are called base angles, and base angles are congruent. So Y is 102. What are the other 2 base angles in the picture?
78.
Yeah, but which ones are the base angles? X and Z are the other base angles in the picture, so X and Z will be congruent. And what did you say X was?
78.
78. And why is that?
Because I equal 180.
Yeah, because your angles along the legs are supplementary. Your angles along the legs add to be 180. So as long as the angles are up against a parallel side, that makes them base angles, and base angles are congruent. Okay, so looking at number 2, is this 70 a base angle?
Yes.
Yes, because it's up against a parallel side. What's the base angle that would be congruent with it?
Z.
The Z. So the Z is 70. And how much would X be? X would be 110, because your angles along the legs add to be 180. So X is 110. And what would Y be? 110. Y would be 110. Because those are base angles, because they're up against the parallel side, and base angles are congruent to one another. Okay, why don't you put both of these pictures in your foldable? So after you lift up the trapezoid, you should have like the whole green section. So you can put one problem in the top section, and you can put 4. I believe this is all we're putting. Until tomorrow. And I say, hey, let's add another picture. So draw 3 in the top green and draw 4 in the bottom green, and then we'll go over them.
Sorry, how about 3 and 4?
Yeah. What? Did you really? Oh. You're an idiot. Bill.
Yeah, you know that, right?
Not in my group anymore. Yeah.
Where's your foldable? Did you fill out the other part? Hey, I really don't have anything for you, but you're welcome to just sit. Well, no, I could give you something to do. Not today.
I think I can just sit.
You can just sit and hang out.
Are you in this class?
I'm peer coaching. What are y'all doing right now?
They're drawing these little pictures and they're foldable, and then we're going to go over them in just a second. Fun, huh?
This is going to bring back memories.
I
That's
hope
a kid sophomore year, and I was like, yeah. The part where it's remembering, like, this is because of this. All that stuff wasn't fun.
Were you in a regular geometry or were you in the...
Just regular.
Okay, you have your pictures?
Yep.
Okay, so let's look at number 3. Can you tell me what y would be?
120.
120. Ready?
No, you're not.
Let's go. The y is 120, which a few of you told me, but I did hear a few 60s. These are angles along the leg. They're not angles along a base. So these are supplementary. So what would z be? 120. The y and the z, those are base angles because they're up against the base. They're up against the parallel side. Okay, so what would you do to figure out the x? 5x equals 60. The 60 and the 5x, those are base angles because they're up against the base. So if I set 5x equal to 60, how much would x be? 12. Beautiful. Okay, let's look at the next one. When you look at the 6x and the x plus, or the 8x plus 40, would you set those equal, or would you say that those are supplementary? Supplementary, because they're up against the leg. So the equation would say what?
6x plus 8x plus 40 equals 180.
Very nice. 6x plus 8x plus 40 equals 180. I can combine my like terms. What do you get if you combine your 6x and 8x? 14x, and then I'm just going to recopy. Then what would you do? Subtract the 40. I don't want to show it. What do you get if you subtract the 40?
140.
140, and then when you divide?
110.
Just 10.
Not 110.
Just 10.
Don't say 110.
Okay,
Someone else said 1.
and if I wanted to figure out why, what could I do?
Plug in the 10 for 8x plus 40.
Exactly. Plug the 10 into the 8x plus 40. So if I put 10 there, what's 8 times 10?
80.
80 plus 40?
120.
So if this is 120 degrees, what's y?
120.
120. Beautiful. Okay. Another thing we have about the trapezoid, and we put this in here, that diagonals are congruent. So if diagonals are congruent, let's look at this picture. Is DF one of the diagonals?
Yes.
Is EG the other diagonal?
Yes.
So what would I say?
4x.
2x plus 16 is equal to 4x.
Yeah, they equal because diagonals are congruent. So we have it in our foldable, and it also says it right here that your diagonals are congruent. So we put it in the foldable. What other shape has diagonals that are congruent?
Wait, what?
What other shape has diagonals that are congruent?
Parallelogram.
Man,
Guys, I saw the
The rectangle. The rectangle. Guys, you have your foldable right in front of your faces. The rectangle has diagonals that are congruent, and the isosceles trapezoid has diagonals that are congruent. Okay, what do I do to solve this?
Subtract 2x.
Good. Let's subtract the 2x, and I get 2x equals 16, so x must be...
8.
Very nice. You guys are very excited today. Because it's hump day? It's hump day! Why? It is? Huh. I think, Autumn, that I will continue to do it then. Okay, I want you to try number 1. Let's see what you get. Take a second, flip your paper over, try number 1.
Oh, good. It's about time.
Oh, wait, which number are we doing?
Number 1. You already did it? And then I'm going to draw some sticks. Okay, Autumn. What's X? I don't have my new Autumn in my stick pile yet. Why? Why? No, like, because, how do you know why? Good. Okay, when you look at the X in 111, guys, you need to stop talking while I'm trying to talk. Are these two up against a parallel side? No, this is a parallel side and this is a parallel side. These two are not up against a parallel side, so these are not base angles. If it helps you to turn your picture like this, you could turn your picture like this, and then you could see that these aren't base angles. So yes, X would be 69. And then, oh, no Christian today. Gavin, what would Y be? It's also 69. The X and the Y, those are up against a parallel side, so they're the base angles, so they're congruent. I just wondered if turning this trapezoid sideways would throw you or not. Okay, take a second, try number 2, and I'm going to draw some more sticks. Yes, ma'am. Oh, yeah, sorry. I must have forgot to put them in the picture. I will add them right now. Boop, boop. There you go.
Oh, you're like pushing it down.
Okay, Cooper, I want you to tell me how you would find X.
Thank you. 3x plus 15 equals 60.
Good. 3x plus 15 equals 60. The 3x plus 15 and the 60 are base angles because they're up against the parallel side. And then what do you do to solve that? And when you subtract it, you get, and when you divide, you get 15. Okay, next stick. Emily S., can you tell me what Y is? 120. Those are angles up against the leg, so they're supplementary. And Austin T., how about Z? Are they up against a parallel side or are they up against a leg? Here's a parallel side. See how the Y and Z are up against the parallel side? So they're congruent. As long as they're up against a parallel side, they're called base angles, and base angles are congruent. So both of those would be 120. So these two equal, Austin, because they're up against a parallel side. These two equal because they're up against a parallel side. If they're not up against a parallel side, they're supplementary. So those two add to be 180, and those two add to be 180. Okay, number 3. I'm just going to draw a stick. And Angelica, can you tell me what I could do for number 3?
Yeah.
3x plus what? There we go. 3x plus 5 equals 5x minus 1. And that's because there are congruent legs. They have tick marks. It shows that they're equal to one another. Okay, take a second, solve that. Good.
It's too easy, Miss Wood.
Well, I guess that's the reason why you're just talking the whole time that I'm talking, right? So because it's so easy that it's okay to be rude?
Yeah, I guess.
Andrew, I don't think you have any room to talk.
I've been talking the whole time.
Hey, you're more like an idiot.
You have been talking.
But you guys be respectful and stop talking,
Yeah.
period.
You guys are talking too. We have a lot of people talking today. Okay, Masha, what did you get when you solved that? This one? X equals 3. Do I need to show the work? Okay. And going to number 4. It says something about RT. RT is this diagonal. It says something about SU. SU is this diagonal. So, Savannah, can you tell me what you know about these two diagonals? They're congruent. So if these diagonals are congruent, what would your equation say? Go ahead, Savannah. Sorry. 2x minus 3 equals x plus 1. Okay, Mark, can you tell me how I would solve that? That equation. What can I do to solve it?
X equals 4.
I know, but what do I do?
You minus x and then 2x and add.
Okay. So I subtract the x, and then I drop everything down, and I add the 3, and I get 4. Okay, so that's your isosceles trapezoid. For the most part, you feel okay with that? Yeah. I have one other kind of problem that we haven't got to, but I'll probably wait until tomorrow, and that has to do with that one that you guys added in to your foldable about the median, so we can talk about that later. Okay, the kite. This little box kind of goes through what I was trying to say earlier, that BD is congruent to itself by the reflexive property, and you end up with these two triangles being congruent. Tommy, why did you say these two triangles were congruent again? Side, side, side. Okay, so I'm going to go ahead and mark up this picture, even though we already marked it up in the foldable. I know these two angles equal. I know this whole big angle here equals this whole big angle here. I know this little one here equals this little one here. And that's because those two triangles are congruent, so all their corresponding parts are congruent. And then we also know that the diagonals are perpendicular. So what's that mean?
Wait, what was your question?
If the diagonals are perpendicular, what's that mean?
There's a 90-degree angle.
90-degree angles in the center. Okay, so let's look at number 1. Number 1, what would x be?
90.
90. I've got 90-degree angles in the center, so I know x is 90. Okay, how about z?
32.
Z would be 32, because we know that these two little angles up here are congruent. And then, how can I figure out y? Yes, add the 90 and 32 and subtract from 180, because we've got this triangle going on right here. So what do you get if you add the 90 and the 32 and you subtract from 180?
58.
58, beautiful. Okay, why don't you put picture number 2 in your foldable, and then take a second and work it out. Actually, never mind, because picture number 2 is just like picture number 1. Put picture number 3 in your foldable and work it out. And then I'll draw some sticks. So put picture number 3 in your foldable in the kite section, and then take a second and find your x, your y, and your z. Excuse you. We ready? Okay, Heather, I'm going to start with you. What'd you find your y to be?
90.
Y is 90. I know my angles in the center are 90 because those diagonals are perpendicular. Craig, how about x?
72. Yeah.
72. This is an isosceles triangle, right? So I know that this angle right here equals this angle right here. So x is 72. Beautiful. And Colton C, how about z? 18. How'd you get it, hun?
I added up 90 and 72.
Beautiful. You add up your 90 and 72 and take it away from 180, so z is 18. Okay, go ahead, put picture number 4 in your foldable. And then we'll talk about it. So you're splitting your time with me and who else?
I'm not sure. We're talking about there's not a lot to do for a certain period of time, and I'll just look out someone else and stuff like that.
Are you okay doing not much? Does anybody by chance think they know what X and Y are? Mickey, what do you think?
118.
How did you know?
Because I took 360 minus 80 and 44, and I got 236 and divided by 2.
Yes. We know that these two big angles right here are congruent to each other, and the 4 angles add to be 360. Anytime you have a quadrilateral, your 4 angles add to be 360. So you do take 360 minus, and I went ahead and I just added those together and got the 124, and you do get the 236. So these two angles together make up the 236, and then you do divide that by 2. And so what did you say you got when you divided by 2? 118. Beautiful. So X is 118 and Y is 118. Okay, I have a little assignment for you on the trapezoid and the kite. So let me get those passed out.
Slightly worried. I'm gonna hear.
If you ever feel like you walk around, you're welcome. Yeah, I think this is my first time in here. Shut up. I think I made what do you mean? Algebra twice MMA. Oh, sit down, buddy. No.
Greg, how are you?
Your desk is
Look at him going here.